I received my pneumatic valve today so that I can finish a very simple setup of a system. I can share this setup with you, tell you what components go into it, and how those are familiar across various systems. So then you should be able to know what kind of things do I need, what's the total cost and total effort that goes into making one pneumatic actuator go to work. We have a reservoir. There's pressure bound in here, and when I press the lever, then it also will equalize with this tube. It will drop just a hair and then fill up the tube with pressurized air. So you may hear it just a little. Nope, not that time. It was already equalized. Okay, then the pressurized line reaches the input port. They labeled this P, I believe, on all these typical valves. I'll call this a valve because it's a valve. Some of them are actuated electrically, and this one is actuated manually, and that's what I needed to basically put together the simplest possible demo. It has the pull condition and the push condition. You notice it sort of died off on that stroke. That's because we ran out of the air in the supply line. And so what I'm going to do is I will get a clamp and I'm going to clamp this down. So that's just an open line now. And let's check how much pressure we have in this reservoir. So we have a Schrader valve. I purchased that Schrader valve on the formerly the dial indicator, the pressure indicator that we had in there. It was a 1/8 NPT. Anyone with a wrench can take one of those off, but the special effort was to heat it up because there's some thread lock substance on there, and you need to essentially partially melt that thread lock so that this will come free. So I put my $2 brass Schrader valve on there just like a bicycle, and then when we push here, we've got 40 something PSI. The air we're breathing is 15 PSI, 14.7, and so we have relative to the air, 30 would be 2, almost 3 atmospheres. So 4 atmospheres absolute, 3 atmospheres gauge pressure, and so 4 atmospheres is how much force we'll be able to drive into this. Very quickly, what's the recommended gauge to be working with pneumatics? I really like this one if you're dealing with Schrader valves because it keeps the value. It has a small volume in here that takes in some air, and then you can release it when you're ready to go back to zero. So that's, I don't know, $8 or so, and there are many like this that do not have that function. You just have to look for the product that has this little button, and then you'll get this. And you also don't want one of the the range to be way too high because then you don't have much resolution. This one's 60 PSI. And to work with this stuff, you probably want up to 150 or 200. In those ranges of pressure, it's fairly safe to work with, it's fairly safe to work with most of the fittings and stuff with just your hands. Eye protection is a smart idea, but what I should mention is that you have enough strength in your hand to form a seal between two different devices. This one has inside of it just a rubber, all the fittings between two metal parts will likely have a rubber little gasket. And so imagine one cylinder touching this face and one cylinder touching that face, and just the force of your hand is enough to fully seat it. And then whenever you're not fully seating it, if you're wiggling it, that's when you'll hear a little pss, pss, air coming out the sides and stuff. But yes, I'm acting against the full force of that pressure on a small circle when I hold this up to the valve and take a reading. The lines that we're working with that you can cut to length very easily with any shears or even just a knife. This is 4x6, And so I found that it's fairly common for small actuators to have fittings that are push to connect, either brass or steel, and they are for 6mm lines, not to be confused with 1/4 inch, which is 6.35. And so you should have a wall that looks like that, and you should have you should be able to read very close to 6mm on the exterior of it. The roundness matters, the not kinking matters, and I believe this is a polyurethane material. So it's a little bit more, has more toughness and springiness, sort of like rubber. It's a little bit more like rubber compared with the other very common material I'm working with, that is LDPE, HDPE. So these hoses I have in a very similar size, the 1/4 inch, for another array of systems. But for the pneumatics, I'm always using this blue stuff so that you can tell it apart, and it's always 4x6. So you're going to find actuation products and valve control products, and they will usually come shipped in a little cardboard box, and they'll have bare ports. The most common port that I'm finding is 1/8 inch NPT for this size. It goes up to 1/4 inch. 1/8 inch NPT looks like this, and it's always going to need the thread tape. You'll find the threads on your steel parts. Seems like in the last couple of years they are always shipping with this little coating. Let's see if we can find a fresh, unused one to show you that coating. What do we have here? Aha! This one's not been used. Very quickly after using it, then we have the white thread tape that starts to blend in and look like it's the coating stuff. Let's look closely. So this is the look. It looks very consistent, but it's because it's, I don't know, a polymer or something. It's very easily worn away after you insert and remove a couple of times. I thought maybe this is here to take the place of the thread tape, so very rapid, easy installation. And I believe that is the intention, but the parts still ship with thread tape, and I don't get any guaranteed seal, it seems, when I just use this and no thread tape. So how much thread tape do you use? What does it look like? How do you apply it? I have gone to Lowe's and purchased a much better material. You're going to get some of this sometimes in if you buy any kit with a valve. They'll throw in a little bit of this PTFE Teflon, but this one, if you're familiar with PTFE, this one feels weird, kind of like foam, and it's ultra thin such that if you try to cut it straight, it's just going to wrinkle. So just throw that in the trash. And my recommendation is this, because now I can count exactly 2 turns with 2 layers, or sorry, 4 turns around a fitting will get you, it's getting me a seal every single time. It's extra thick. So how do I work with this stuff? Well, it's much easier to handle and have it held straight. And then I'll cut off a segment this long, I don't know, call it 6 centimeters. And then normally you would take this and you're going to wrap it in a direction such that threading the fitting into the female will not peel back the tape. So it's the direction I'm showing you now. But if you hold the tape at the full width, obviously you're going to have this extra stuff. And so I don't do that. I take it, if it's the type that you can actually work with, like this gray stuff, then I'll actually fold it over. This is my latest method. I can fold it over for these very small 1/8 NPT fittings. Okay, now I have approximately a double layer, and then 2 wraps. 1, oh gosh, it's hard to film and do this. 1 and 2. If you have a little bit hanging over, it doesn't matter. it's all fine. If a little bit of this hangs past here, the air will blow it through anyway. All right, then this is going to go into your female 1/8 inch MPT. It should feel smooth and consistent such that the torque of any wrench that you use is going to be, it'll feel like it's a constant, gradually increasing torque required. And because these are tapered fittings, you will not always have it drive all the way in. Depending on however deeply they tapped the female, and I'm going to go, basically, I don't extend any further, gripping this further than the width of my hand, because that means I'm putting some monster torque on it. So I'm basically at most hand tight at this level. Okay, so what are these things? I told you this is the manual actuator, and this one is the electric one. It's rated for 12 volts. So this goes together using DC power, same voltage as the very most number of actuators that I have. And it's as simple as once you activate by sending the 12 volts, then this is going to switch. If it's a normally closed air path, let's see, does it tell us? I can't remember, but you can blow on this like a balloon. Looks like somebody marked the direction for the flow, and it's normally closed. And that, I think this makes sense because you have no energy going to it and no airflow coming out. This is the configuration I think you should choose as your default if you don't have a criteria to choose by. It's rated for 4 watts. So while you power it up, this solenoid inside of here, it's a little coil. It takes a little bit of current, and it's going to be driving a steel pin down that moves the valve. And while it's held down, then it's going to be using 4 watts at that time. So that's a gentle amount of power. I could desire a lower wattage, but that's very reasonable. Okay, so the conditions of this valve, let's talk about that. In one condition, you have a continuous path from the pressure side to A. That's the condition right now. And in another condition, you have a continuous path from the pressure side to B. And when I move this, the airflow will move and actually pass in this direction through A and out to one of these little vents. So right in that action, the air went a little bit in this direction and this direction and this direction, and out through probably this R vent. These vents are nothing more than a centered little piece of brass. It's I think they're called mufflers, not vents, and they somewhat silence the whistle. They reduce any extreme jet of pressure that could blow out of here and startle the kids. So at this condition, we have this tube is like a pressure chamber, and this tube is like a free flowing straw that passes the air. And when I compress this, then there is no change in the amount of air in this volume, including this and this inside the cylinder. And on the upper side of the cylinder, then we have a changing amount of air. So right now it's near 0, and then this amount of air is connected to it. When I push against the pressure, then some air will reverse and enter in this direction. If you can picture basically filling up the void that follows the end of the piston while I'm doing this. So now we have like a spring basically, without any extra energy, without any changes to the system. You could have this basically following along and closing the gap of an apparatus, basically maintaining pressure. So if you have something that you want to hold, then it doesn't matter if it's bigger or smaller, it will still just keep on holding it. And how much force is it holding it with? Well, We had something around 50 psi in there. I'm hearing a little leak. Something here. Oh, down near the base. Okay, something around 50 psi was giving us 4.5 kilograms, and in pounds, 10 pounds. Okay, that actually is not exactly equal. Now, how does the force change based on the stroke? Well, near the start, we had 9 pounds something. Near the end, it's a little bit more, but not a whole lot more. So you have near constant force when it's set up like this. So if I were to double the pressure that I'm feeding this with, then it's going to double the force that I'm pushing with. So let's take a look at where we are pressure-wise right now. Just under 40 psi. And so if I drive it up to 80, then it's going to be double. And you may have seen this in my short videos. Sometimes I'm just using this electric air pump, 18 volt. Comes in the power tool section of the store. And this is ultra loud. So we've come up to 80. We've come up near 80, and we're still in a fairly safe zone as far as handling things. Nothing's gonna explode and hurt me. I believe this tube is rated for 200-ish psi. The piston is rated for something like 100. This one's rated for something like 200. That's the range where you'll find these things. And of course, there's a factor of safety built into all of those. Yeah, so that one I can feel that's almost double, but it's very smooth stroked. You can tell this is polished steel rods and stuff. Super, super nice quality for something like this that I think I only spent like $16 for this unit and another $14 for this unit. So these are items that last forever, and that's how I consider them something that may go into a project and then dismantle the project and use it again in a new way later on. I also ordered this fascinating gadget. That's just another pneumatic actuator, a similar order of magnitude as this as far as the power capabilities. And it's for rotating. So you have two ports just like the linear actuator, and you can feel them. One will expel air, and one will suck in air if I back drive it. What features are of interest? I really like how these seem to be configured so that you could mount them in many different directions. They're, solid mass. This one is sitting at 510 grams, around $30. And then we have threaded holes. I think these are M6. All of this is going to be metric, except for those NPT ports that are very ubiquitous. The alternate port besides the NPT is this one. Yeah, so there's no NPT on this. This is an M5 thread, the very most common M5 by 0.8 millimeters thread. And so it's just the same as a bolt, except with the hole drilled through it. And then it'll have this little ring, this little rubber O-ring that's very replaceable with any old O-ring. If you go and grab spares, this may get crushed if you install it many times, pinched or shredded, and then you can just put a new one in. Nothing magical, nothing exotic involved here. So let's drive this one. Get ready for it. Oh, we got no pressure there, and then some pressure there. So I will hook this one up in the same way. I don't know which one is going to turn it clockwise and counterclockwise, but we'll find out. Oh, I need to prepare my 200 psi rated 1.4 liter cylinder. Okay, so now we've got pressure. Oh, it looks like it's a little bit dampened. Interesting. This one will drive in a very small fraction of a second, and this one's taking like almost a half second to spin. So that's neat. You can probably adjust this damping. I have not explored it yet. Oh, wow. Okay, so what I did was I took this 12mm wrench and I just loosened up this, this stop nut, and I drove in one of these threaded fasteners. And you can see I'm actually indexing the end stop. When I turn this, I'm getting a very gradual adjustment of the terminating limit. So then you would tighten this back up to secure it for good. And then we're going to get a different, I think this is rated for 190 in each direction. We came down to here, and then, yeah. So you can customize the start and stop points. And then I have to figure out what's going on with this. Looks like on one side, now we've got air continually passing out the exhaust. So I'll have to explore that more. I won't waste the time in the video for that. Okay, in the coming months, then I can continue featuring the pneumatics in the places where they belong. But this is just one portion of the spectrum of the send it and spend it, the story of thermodynamics, and where's our energy coming from and where is it going, and how much of it are we consuming when we put together a multidisciplinary system with actuators. Sometimes the pneumatics characteristics are just far advantageous compared with a pure electrical thing, and I don't want to be confined to just electronic devices. So we'll come and talk about the strengths and weaknesses when I encounter some side-by-side options. Then I'll bring that into my designs that I'm publishing that are listed under Open Lab, and I'll bring that into the discussions in these videos. So anyone else who's already have experience with these, welcome to the community. We'd love to have your experience, maybe share what your favorite actuators are or your favorite use case, and if you've seen in the wild any open source designs, open source engineering systems that have been developed that include these things. One place that that you could get resources for this, it is Misumi. It is a Japanese supplier, kind of like the McMaster car of Japan, and actually all across Asia. It's a very popular, high professional level for distribution of engineering components. And so they have, I'm certain, at least in one section of their website, that multiple systems that are already configured with CAD models and specifications like the torque and the pressure and the full suite of basic engineering specifications for a given system that has been designed already and configured with all off-the-shelf components. It's just this stuff plus Misumi's fasteners, very standard common things, a few different photos of or drawings of the apparatus, and that's really cool. And so that could give you a launching pad for a system you want to design, whether it's going to clamp down items on a table, or it's going to index items in an assembly line, they have these sample designs. So I'm aware of that. It's not exclusively for pneumatics, but yeah, these components, I just purchased them on Amazon. You can find lots more there, and it looks like, I think I've encountered 3 sellers so far, 3 manufacturers. They've all been just excellent quality, no issues at all, and definitely worth the price that they're charging. So thanks everybody, and I'll see you next time.